Hey, welcome back to Verbose DevOps. I hope you're good. Today we're going to look at one of the most famous and also makes you want to pull your hair out Kubernetes pod errors, and that is the legendary ubiquitous CrashLoopBackOff error. Quite difficult to say sometimes. So I just want to say, by the way, before we get in there, if you haven't already, please, if you want to, anytime, give this video a thumbs up and subscribe as well. But let's take a look at why you can get this. So the biggest case is misconfiguration, and it can be bad syntax or a typo or maybe the wrong image, missing dependencies, missing environment variables, wrong environment variables, command line arguments, probes, misconfiguration, resource constraints. So these are all misconfigurations. But it can also be, for example, networking issues like a global issue, DNS, or your connection, a major connection has gone down, or just an external dependency you rely on. That can also be, if there's an issue with that, can cause an error. So remediation, we're going to look at pod logs. We're going to describe the pods to get events, pod events. We're going to review the manifest for misconfigurations and also the Docker file and any other configuration that's relevant to what we talked about up here. And we're going to review the app code, but I want you to think about external dependencies as well, so that when it links into the networking issues, but also in general, think about when you're troubleshooting this issue, did it just suddenly arise, or was it preceded by someone taking an action that could have led to one of these things? If nothing really changed, then maybe you could be looking at some kind of network issue. But if it was preceded by an action, that's probably a big clue. There are also some commands that are going to be useful, so describe the pods, and this is how to get also pod logs if you want them, pod logs on your entire namespace, or you can just look at a single pod, which is probably what we're going to do. kubectl top pods is to look at CPU and memory usage, which we will be doing, and if you want to get a global view of all events on the cluster, you can use get events all namespaces. So with that said, let's look at the first example here, and what I'm going to do is I will explain these files, but the first thing I'm going to do is I'm going to do an apply on the manifest, and this is just a replica set, that's all it is. So what I'll do down here is I'm going to keep this running the whole time. I'm going to run a kget pods, watch it so that it's real time, and the namespace is going to be PyLogger. So there you can see there's 3 pods running, and I will just show you as well if I look at any of these pods. So I'm going to look at in fact, you know what, let's look at all of the pods. I'm going to say PyLogger logs minus f, label is app equals PyLogger, and all containers equals true. Then what you're getting here is this, all this program does, this Python program, it just generates information of logs, and you can see there's a 999 and a 101010, and that's just all 3 pods writing the same message every 5 seconds, I think it is. So we can see that it's working. It's obviously not crashed. The status of these pods is running. And if I were to go k-n PyLogger, describe one of the pods, so for example that pod, then you can see that it successfully pulled the image and no issues at all, which is great. So what I'm going to do now is we're going to mess this up. So I'm going to edit the Docker file, and the Docker file is pretty minimal. It just says copy the app and then run it, run Python and then space app.py. So what we're going to do is we're going to put this in this is a typo basically, app1.py obviously doesn't exist, so let me save this, and I'm going to have to build this and then push it. So this is a shell script just to build it locally, and then I'm going to push this to the remote registry. This is what's in the pod spec of the manifest. It's going to refer to this remote registry. And now what I'm going to do is I'm going to delete one of these pods, because if I delete a pod, then it will delete pod, it will force download the latest image again. So let's grab one of these again, copy, paste. So you can see that pod has been deleted now, HQ8, but this new one, X79X9, pending, creating, running, error, crash loop back off. In fact, I'm surprised it actually ever said running, because it wasn't really running. But maybe it just thought it was running. But it's in a crash loop back off state. And now it's going to do exponential back off. It's going to keep trying to restart the pod, but waiting a bit longer each time. So what we really need to do now is we need to go back and edit that Docker file again and rebuild and repush the image. We're going to fix what we created here. So let's do that. Save that. In fact, before I rebuild it, what I want to do is I want to show you the pod here. So that's X79X9, and there you go. You can see the events here. It says back off, restart, and failed container. And if I now show you all the pods again, the logs, I'm going to do everything. You're going to see two of them are going to be running okay. Just wait for them to come through. So you've got 45, 45, 46, 46, 47, 47. In fact, what we're getting here, if we look at the latest ones coming through, is only two of the pods are showing logs, and the one that has crashed is not creating any logs whatsoever. And actually, this is kind of what we probably expected, but you would still check the logs if you had a problem. But anyway, we fixed that. We just need to redeploy it. So let's build, and we're going to push this. And what should happen is this image has just been replaced remotely, and so if we wait, we should see that this is going to come back. So let's see. This is crash loop back off. It should come back anytime soon. In fact, what I'm going to do in the meantime is I'm going to try and create another error. So I'm going to go to app.py, and what I'm going to demonstrate here is you got a Python program, or it could be anything, and let's just say you put in you just mess it up. So I'm gonna put in, you know, a dash dash dash. I don't know, or just some junk, right? I'm going to save that. And what we're going to do is we're going to push that image. But first I want to see this application recover, because it's going to recover if you look carefully at the bottom screen. It should recover very soon. So the thing is, it's exponential back off, so you have to act pretty quickly for it to you know what we're going to do? In fact, we can speed this up. Let's speed this up. Let's delete that pod. So we're going to go OK and pylogo, because I'm too impatient to wait for it to retry. And it's going to be oh, there you go, it happened eventually. There you go, running. So now it's running again. It recovered because remember we fixed the Docker file. We put that back. So, and then we did a build, and then we did a push, and eventually it recovered. And now we got a new one. We've just put all this garbage here at the beginning of our app, and we are now going to build this and push this. Okay, great. And now let's push this. Now we see a layer already exists, that's fine. We only made a small code change, and the fact that all this other stuff is cached, that's good. So now what we need to do is we need to delete one of these pods. So let's say delete pod. Let's pick on that pod again, the poor pod that is you know, just recovered. So let's do that. Deleted. Now there's a new one, xkj, pending, container creating, error, crash loop back off. And we know why, but let me just describe to you what it looks like now. If I go kn pylogger describe pod, let me copy this. Damn it, it's moving. It's a bit difficult. Copy, paste. There you go. It says successfully pulled the image, but backing off restarting failed container. Now, if we look at the logs, so I'm going to go kn pylogger logs, tail them, and I'm going to put that pod name in. Then look at this. We do get some logs, and it's actually an application error, and this is a Python error, and it says syntax error, invalid syntax, and it points exactly on line 1 where that occurs. It's where I put that garbage. So let's fix this. Let's go back to app.py. We know why. Correct that. Save it. We need to rebuild it, and then we're going to push it again. Of course, build and push will be something that's in your CI/CD, but in this case we're doing it manually. There we go. And now this should recover. I think we were fairly quick this time, so I don't think it's going to take too long. There you go. I think that's it. Running. If I were just to check all those logs, so let's say, what is this? That one there. And there you go. It's now running again fine. Every 5 seconds it's just the application is running, it's not crashed. So that's great. Okay, so that's one example. Now let me show you another example. So I've got this other application called CPU Bust. And let's just do an apply. And it's a replica set again. This time it's only one pod. So down here, let's change this to CPU bus namespace just to watch the pods again. In fact, let me clear that because it's got some other remnants there. And there you go, it's running. It's running fine. And I think there's nothing in the logs that's worthy of seeing. I'm just trying to remember, but we can have a quick look. But I don't think it writes anything. So let me copy this, insert, paste. Yeah, there's nothing there. And if we were to describe the pod like that, then you see it all looks good. All looks great. Now, what we're going to do is something slightly different. We're going to edit the manifest. And this manifest, it just has a namespace at the top, and then there's a replica set. One replica, so one pod. And what I've done is I've put in some resource constraints here. Now, the reason I called this CPU bus was because actually there's a program in there that slowly grows CPU. And I was hoping that I would get a crash loop back off error when it hit the limit of, in this case, half a core, 0.5 of a core. But actually, it doesn't do that. It just does CPU throttling, and the program never actually crashed. However, I think probes would have caused a container restart, but I don't have probes set up. So instead, what we're going to do is, this is running fine, but what we're going to do is we're going to lower the limit for memory. And I've tested this and it will work. So if I now lower this to 4, which is 4 thousandths, 4 megabytes basically, 4 thousandths of a gigabyte, 4 megabytes. Then let's save this. And what I have to do is I have to reapply this because it's not aware of this yet. So let's do that. And in fact, what I should have done is, what I'm going to do is delete that pod. Oh, CPU bust RSQD5RK. Something wrong in my syntax. There we go. No, that's also not right. There we go. Okay, now it's creating a new one. And remember, I've already applied the manifest, the new rules about resource constraints. And there you go, OOMKilled, and then CrashLoopBackOff. So I gave it a tiny amount of memory. If I'd gone any lower, actually, you know, Well, I did also test it lower, and I got a completely different result. But at this sweet spot, it gets this OOMKilled message, which means the pod was killed because it exceeded the the resource constraints. And now look at it, crash loop back off. So they're great. Yeah, and terminating is actually the old one. So ignore this QDL. We're only interested in ZWHT7. So it's in a loop. So let's fix this. In fact, before we fix it, let's have a look at the logs, just to see if there is anything. So okay, and CPU bust, logs, forward, let's copy that. And there's no logs. Okay, fine. But how about if we do a describe pod? Then you can see the events, and you can see it started a container and then back off restarting failed container. So yeah, interesting that it doesn't actually say OOMKilled in here. So that is interesting, but obviously it says it down here. So yeah, slightly different viewpoints. But let's fix this. So we need to go back to the manifest, and we need to modify this. Let's increase this to, say, I don't know, 10. Save it. We need to apply this. So I'm just going up, apply. Okay. Now I think we still have to kill this pod. I don't think it's going to recover. So let's do that. CPU bust. Delete pod. Copy. Paste. And there we go. And there's a new one called 9G62, and it's running. There you go. If I just remove the W, just a static view. There you go. One pod, and it's running, and there's no problem. And if we would look at the events on that, the events in here, 9G62X, then it all looks good. So brand new pod, and it's not exceeding any resource constraints. So there we go. I hope you enjoyed that as much as I did. Listen, if you like this video, please give it a thumbs up and subscribe to the channel for more like this, and I will see you around soon. Thanks for watching. Bye.